Today we'll present One Step Ahead, Defeating Tomorrow's Security Solutions, Part 1. And I'll explain why it's Part 1 a little bit later. I'm Jeff. This is Joe. This is my first hacker presentation of any type. A lot of you probably look at me and think, that guy definitely looks like a hacker if I had to guess. He's just got that look about him. But I definitely am excited to be here today because NEOISF is where I started when I was new to security information, and I learned a lot in this room from a lot of different people that are already sitting in here. So happy to be up here. Joe is a principal software engineer, and he is a coder for a security vendor. All FUD. That's what we do, right? Security vendors are FUD. We actually try not to do that. We take a different approach. What we like to do is have open and honest conversations about what our products are, what their capabilities are, how they can improve a company's security posture, and let them make decisions from there. It's more about where is that security bar set, how much can we raise that bar for you, and making decisions based off that, not the fear, uncertainty, and doubt thing. As security vendors, though, it's also about understanding malware. It's about understanding other security vendors and what they're offering so that we can place our products within that security stack. So that's a little bit of what we'll talk about today. And again, thank you to NEOISF for having us up here. This is again, sort of short notice that we got to present, so happy to be here. So a little more. We are a Cleveland-based company, so if you don't know me, please feel free to get to know me. I do know a lot of you already from my previous NEOISF experiences. And Joe is from Palo Alto. We are originally both from Cleveland, and ItSoftware, our company, is a Cleveland company, so homegrown. Today's discussion, we're going to go through the threat landscape. We're going to talk about application whitelisting in depth, and then go over some security suggestions. So the threat landscape, it's dangerous out there when you think about malware, mainly because of ninjas, pirates, lasers, and other things. So malware, as far as that landscape goes, is very prevalent. It's a good time to be a malware writer. There are two big reasons to write malware today. One is for profit, right? There's a pretty large criminal underground that if you're good at writing malware, you can make a tremendous amount of money. Sort of a side note with that, I saw this week that the guy that hacked into a bunch of celebrity emails and ultimately posted those photos of Scarlett Johansson got 10 years and a $66,000 fine. So out of curiosity, I looked up what the latest ATM hacker got when they were sentenced, and I found an article from August of this year. Apparently a woman that had stolen a few $1 million and over 100,000 credentials, her and her crime ring, was sentenced to 2.5 years in prison and a $90,000 fine. So I think the moral there is, if you're going to hack for the dark side, keep your eyes on the prize. Don't mess with celebrities. It's kind of interesting. And then the other reason would be cyber espionage, right? It's something we think about a lot at ItSoftware because we are a security vendor for Avnet, who distributes more Windows embedded operating systems than anybody in the world. And when you start thinking about embedded devices and what they do, you're starting to talk about infrastructure, those sorts of things. So cyber espionage is something we think a lot about at ItSoftware. But those are the two big reasons. I'm either going to make money or do nasty things to other countries. Malware is avoiding conventional security measures. I believe a lot of people in the room are probably well aware of that. I've seen people in this room defeat antivirus, firewalls, IDS, IPS, UAC, right? Those are all things a lot of people in this room themselves can write exploits to do. So doing the same old when it comes to malware is certainly not going to bring success to your organization. So different approaches become necessary, right? A new breed of antivirus is born. So what we've seen so far from the industry is application whitelisting and behavioral analysis. What we're going to talk about more in depth today is application whitelisting. That's why today is part 1. Behavioral analysis would be part 2. At that point, Joe will probably be back in California. If you guys find this one interesting, want to see part 2, I can come in and parrot what people more technical than myself tell me to say. I'm good at that. So let us know. So despite rampant malware issues, these two solutions have not been widely adopted. And there's multiple reasons for that. We'll talk a little bit, or not a little bit, a lot about that with application whitelisting today. But malware has techniques to deal with both of these solutions already. Oh, sorry about that. Apparently I'm going to skip ahead. You can cause unwanted behavior in the solution. False positive, those sorts of things. It's a less desirable way to attack an alternative solution, but it's kind of an investment from the malware writer, right? If I can punish an organization for adopting a security solution, I can ultimately prevent that security solution from becoming popular and becoming a problem for me as a malware writer. You can disable a security product by attacking it. Whether you want to disable it permanently or temporarily, that's oftentimes an option, one way to get by. You can bypass the method of detection, which is a fairly obvious self-explanatory thing. And then you can directly alter the behavior of the security product. You can alter the way that security product is actually operating in such a way that it would allow you to infect a machine and do it in such a way that that product appears to continue to be operating when in fact it's not. Did I miss anything? Okay, so with that, I'm going to turn it over to Joe, and he's going to talk about these 4 things more in depth with respect to application whitelisting.
Thank you. As was mentioned before, if you have any questions, feel free to stop me along the way. The more discussion, the better. So first of all, we're just going to go quickly over what application whitelisting is so we're all on the same page. And essentially what you're dealing with is a solution that is kind of the opposite of signature-based solutions that you see in antivirus. So signature-based solutions assume everything they don't know about is good, which tends to be a pretty bad thing when you're developing new malware on a daily basis. What application whitelisting does is it says anything I haven't seen before is something I'm not going to trust. It's going to be known as an unauthorized piece of software. And what that allows them to do is be more effective against new threats and the things that have been designed to bypass signature-based detection mechanisms, because the zero-day threats that are created that require an application or new application are going to be detected by this because they won't have been seen before. And it also doesn't matter how you launch that particular executable, whether it's some sort of exploit that caused that exe to launch or something along another line. The actual method of attack isn't going to be a particular issue. And once it detects something, it basically has 3 choices. It can either prevent it from running entirely in order to keep it from doing its damage. It can prompt the end user to ask them whether or not they want to run the unauthorized software, which is typically something you don't want to give that power to your users. Or it can simply audit that a unauthorized binary was launched and then report it back so that you can see something suspicious is happening inside your organizations. So while this is definitely an improvement on just signature-based detection technology, there's still ways that it can be defeated. The vulnerabilities that exist in application whitelisting exist regardless of what mode you're running it in. So even in its most secure mode of operation, there's going to be ways to exploit it. I broke it down into 4 different ways. So the first one is you don't have application whitelisting today in your environment. If you go to install it, you might have malware that's already present on those computers. And what can malware do if it's present when you're going to install the application whitelisting product? Well, one thing it can do is just stop the installation entirely so that you can't successfully install that product on it. If it wants to be particularly smooth about it, it can make it appear as though the application whitelisting product encountered some sort of error that wasn't related to it, so that you go back and yell at the vendor that their product doesn't install properly. Another alternative is simply to be grandfathered in, because the way a lot of application whitelisting solutions work is they accept anything that's present on the computer at the point of installation, so that it's easier to deploy the solution into an environment. So if it wants to, it can just remain there, do whatever it was doing before, and it'll be able to do that without issue. Or if it wants to be particularly effective, it can actually modify the installation in some way so that in the future it can download its own additional new pieces of software, but modify the way the security product sees it so that it won't be recognized. Beyond that, one of the major vulnerabilities is simply to exploit an application that's already been permitted in the whitelist. So you have things like Internet Explorer, Microsoft Office, Adobe Acrobat, Java, whatever. These are very common in environments and often exploited to launch malicious code. Well, if you can exploit IE to run something, application whitelisting isn't designed to detect that because it's not a new binary of some sort that's running. And if you want to continue to exploit that, you can either redirect users to that web page, for instance, or you can install something in the registry that automatically launches a PDF you happen to have launched an exploit out of so that it's constantly running. But I think the two that are kind of the most interesting are the certificate exploits and the kernel driver exploits that I'm actually going to demo for you. So basically, I'm going to make a few assumptions with this demonstration. And what it comes down to is, you can give entire talks on these assumptions. So first of all, some malicious action is capable of taking place on a computer. So someone has either exploited a whitelisted application in order to run their malicious code, or they've hacked directly into it, so now they're able to take control of it and directly modify it, stole credentials from someone, RDP directly in, and now they have control over it. That's the first assumption. The second assumption is they're able to gain administrator rights through some account. So they're either exploiting an application that has those rights, or they've hacked, they've managed to increase their credentials to gain that. And then the third thing is that user account control isn't going to be something that stops them from performing their actions. So the demo I have for you is based on those assumptions, and I will show you what we're capable of doing. So I have loaded for you a VM, and hopefully it'll cooperate for me. So inside of this virtual machine, I've installed an application whitelisting product, and the intention is not to pick on a vendor, so I've basically hidden any reference to this particular product. What I've done is I've installed two legitimate applications on it. We have Procmon, a sysinternals tool. So if you were going to look at this from an outside perspective and you didn't know this was a good application, this might look really suspicious. It's capable of monitoring what sort of activities are happening on the computer. It's capable of recording that, tracking it. So, from an outside perspective, that might look malicious. Similarly, and you'll see that this is allowed to launch. Similarly, there's this cross-loop application, which is a means of RDPing into a computer, essentially, to take control. Again, from an outside perspective, if you were looking at it, it might appear suspicious. What we've done here is we've said, okay, I want these things to run on my computer. And the way I'm going to allow these to run is I'm going to register their certificates with the application whitelisting product. And what that certificate does is it says, okay, this piece of signed software is allowed to run on the computer. And the reason they do this is because it makes it a lot easier to manage an application whitelisting product. Because if you have to know every single executable that runs in your environment, it's a management nightmare. But if you can say, okay, I trust all certificates from Microsoft, or I trust all certificates from Adobe, it's a lot easier to manage the solution. Yes?
Why would you assume that, considering that Adobe and Microsoft in not too recent times have both had problems with certificates?
I agree entirely. And that's kind of what I'm getting at too. And I'll go into more depth on that a little bit later. But yeah, that's one of the problems. Making these assumptions is particularly problematic. So we have these legitimate applications we're allowing to launch in this particular instance. Now what I'm going to do is have this application over here. Let me hide that. Not one. So we have this fake malware exe. So if I try to launch this, you're going to see that it tells me that it does not have access rights to it. If it will hurry up. And the reason it doesn't have access rights is because this particular application isn't known by the application whitelisting solution. There we go. It was hiding. So it says, Windows can't access the specified path. You may not have appropriate permissions to access the item. So we can't launch this application because the product doesn't know about it. So, if this is malware, it's done its job pretty well. Again, I have another malicious application. Again, won't allow it to run. And that's despite the fact that this fake malware even comes with a certificate of its own. So on this, I've attached a digital signature from the fake malware cert, but because it's not a trusted certificate provider, the product's not going to allow it. Now, the issue is measures can be taken to subvert this certificate authorization process. And what I'm going to do is demonstrate an exploit here where I'm going to point this application whitelisting product to a fake certificate store I've created in order to perform an exploit. So first thing I'm going to do is I'm just going to move the certificate for fake malware.exe into this fake cert store. So at the moment, I haven't engaged any of the capabilities yet, so it's not going to be allowed to run. It's still going to get blocked.
What is a fake cert store?
It's certificate store. It's where they store certificates.
On the local machine?
Yes.
Okay.
So it says you can't launch it. And then what I'm going to do is I'm going to execute one registry command. Since application whitelisting isn't designed to block any sort of registry modifications, this is going to be allowed to work. So now, in order for this to take place, I just have to restart the computer. So I'm going to restart. Now, the reason these types of exploits work is because application whitelisting products tend to need a local storage mechanism for their certificates. Because if you don't have that, then you're in a situation where either you lose network connectivity and it nukes everything on your computer you wanted it to run, or you're allowing everything to run on the computer in those instances and you created a new exploit that malware developers can target. So by keeping it on the local system, they're able to prevent that sort of hole. But because we can leverage existing changes to change where it looks for those certificates, we can trick it. So before, you'll notice that proc monitor and crossloop would work successfully. Well, their certificate is no longer in the legitimate certificate store used by this application. So when I go to launch it, now all of a sudden I can't launch process monitor. If I try to launch crossloop, I can't launch crossloop. And what this allows a malware developer to do is do a denial of service attack. So if they want to, they can basically neuter your computer and prevent anything from running on it. And to you, it's going to look like your application whitelisting product just completely freaked out and did something wrong, so you're going to go on a forum and swear about it. In reality, what's happened is malware's managed to change the way it's working. So what we can do is we can, go to our fake certificate store, and we can. And then the other one. We'll move these legitimate certificates into our fake store, and now all of a sudden you can launch it again. So you don't have to do a denial of service attack. That might be caught. That's something they can see. Rather, you can do something more subtle. We take that out, we can prevent a specific application from running, maybe one that we don't want to run because it provides some sort of security technology. Or we can allow everything to run and make it appear as though it's working properly, but all of a sudden, our fake malware exe, because we added the certificate to that fake certificate store, is now allowed to run on the computer without any sort of issue. So from your perspective, it looks like your application whitelisting product is working perfectly, but now I have complete control over what software is going to run on that computer, whether it's malicious stuff I want to run, or whether it's legitimate applications I don't want to run. So that's our first exploit. And as you can see, the one I didn't permit still being blocked. So that's essentially the first compromise I have, and that's the certificate exploiting mechanism by taking advantage of the the reliance on these certificates to allow software to run. Does anyone have any questions on that?
Web entry just repointed or redirected where your cert store was? Is that
Correct.
right?
Yeah, it was a
So why
technique.
didn't you just copy the cert into its current location?
Because most application whitelisting products are smart enough to protect that store, but most of them are not sophisticated enough to detect the fact that you've changed the location to which it points. So I've managed, there are 3 or 4 different ways to actually do it in this particular instance. It's a little hackery with junction points. So that's our first exploit of application whitelisting. The next one I find a little bit more interesting. So we're going to go back to our original state. And this time, instead of trying to target this sort of certificate vulnerability that's exposed, we're just going to take advantage of the architecture of these products. And by that I mean all the application whitelisting products I tested use kernel level drivers in order to implement their functionality. And there's a really good reason for that. Like, kernel level drivers allow you to basically monitor everything that's going on the computer, on the file system, or in the registry. So it's a really easy point for them to be running at. They can see everything they need to see to implement their sort of security functionality. The other good thing about it is that they can modify the results of those commands. So for instance, fake malware.exe, which you have normal permissions to if that product weren't in place, isn't able to run, because when you go to launch it, it says, the filter driver says, I don't want this to run, so it gives it an access denied error. So what we're going to do here is we're going to take advantage of the fact that it needs this kernel level driver to perform its function in order to block something. And we're going to slip another kernel level driver directly underneath it so that that driver loads before the application whitelisting products driver is ever loaded, so that you essentially gain all of the control it had over it. So the way we're going to do that is we're going to insert this, we're going to install this driver from within the account. Now, many of you may be aware already that Windows 7 doesn't allow you to use an unsigned driver on a computer. Now, there's some pretty smart people who have managed to exploit this and have found ways to get around it. I opted for something a little more elegant. I took an existing driver called callback filter. And this is a driver that exists and is sold by another company so that you can gain access to that kernel level code without having to write these dangerous drivers yourself. The problem is I can use that to implement my malicious desires with it, and because it's a legitimate signed driver, Windows is going to allow it. So the first thing I'm going to do for this is simply move the driver into, I'm not going to double click on it. I'm going to move the driver into the drivers folder. I'm going to install a registry key that basically puts the service in place on the computer. So that's allowed to go. And then for drivers, you have to also add this enumeration root registry key that Microsoft, as you'll see, protects. So if I try to add this on its own, it tells me I can't do it. The intention is to prevent you from being able to install these without going through their mechanism. Unfortunately, Microsoft didn't implement it in the most sophisticated manner. So if you simply go to permissions on that particular key, claim ownership of that particular key, then allow permissions for everyone on that particular key, now all of a sudden that area that you weren't able to edit before for very important security reasons is something that has been trivially bypassed. So what I'm going to do with this particular filter level driver, I'm going to enact some bad behavior. And in this case, I just want to deny access to a particular README file. So I have these 2 READMEs on the desktop. One of them is the README for demo.txt. For now, you're going to be able to see this. But once we implement, or once we enact the kernel level driver, it's not going to work anymore. And then we have this other one for a control that you're going to be able to see forever, because I'm not preventing that one from being launched. So we're going to add a registry key that basically says, I want to put this in place. This is, I want to block this text file from being launched. It's just a capability that's offered by callback filter. So the next thing we need to do, we installed it, but we haven't actually loaded it into memory yet. So we use Microsoft's own loading mechanism to try to load it. And what you're going to see is it's going to tell you can't. Access is denied. And the reason for that is because the application whitelisting process is running currently. So it sees this driver that it knows isn't allowed to launch, and it's not going to allow it to launch. The problem is because this driver loads at a lower level than the application whitelisting one, once we restart it, that no longer is the case. So we're going to reboot now, and what we're going to see is that our driver that we installed now comes in underneath the application whitelisting product and is able to run. And from that position, it's capable of doing lots of malicious things. It can monitor any file system activity, it can monitor any registry activity on the computer, which basically gives it a free run of any sort of sensitive information you have present on there, any delogging capabilities, things of that variety. It can, it can use network commands in order to send out the information it gathers. Or if it wants to be particularly malicious, it can actually hide things that are going on that system and enable rootkit-like capabilities. So the first thing I'll show you is that the application whitelisting product is still running. I still can't launch this fake malware.exe. And then I'll try to load that driver again. So we go to load it. But this time it says an instance of this service is already running. And that's because this driver has already managed to load itself into memory, even though this application whitelisting product is working without any sort of issues. So to prove that it's actually running, we'll look at the control text file. You can still read it as normal. But all of a sudden, when you just want to read a normal text file named readme for demo.txt, access is denied on it. So in this particular case, I did something that was not especially malicious, but if I wanted to, I could use it to hide EXEs that are present that are actually enabling malicious activities to take place on the computer. And once you have that driver in place, you've now managed to gain full control over the computer for any sort of espionage or malicious purpose. So, were there any questions around this particular exploit? Yes.
Yeah, just curious where you ran across that one driver, that callback driver.
I actually searched for it. So there's more than a few of them. Because the problem with the kernel level driver is if you have any sort of error in the code, it blue screens your computer, which means writing them on your own is a really risky proposition. So in order to simplify that, there's a few companies out there who provide these sort of capabilities to legitimate developers so that they don't have to develop drivers themselves. The problem is malicious developers also have access to these, usually don't pay for them, so there's not a trail for it, and they're still capable of implementing these sort of technologies and techniques. Were there any other questions? Okay, so that concludes the exciting demo portion of our talk. And now we're going to get into kind of the now what of it. So that's kind of, I don't mean to paint a bleak picture about application whitelisting. Every solution you're going to implement is going to have some vulnerabilities around it. What's important is that you educate yourself on what those vulnerabilities are. One, so that you know what to look for, and two, so that you can actually take some steps to mitigate it. So with any security technology you implement, I think the first step is simply to educate yourself on it. So if you're looking at a vendor, go out and educate yourself on that topic. And I think the absolute best starting point for this is simply to ask the vendor themselves about what vulnerabilities exist in their products. Because if anyone knows what exists, it should be them. And if they don't, you have a bigger problem on your hands. So the first thing I'd say is go talk to a vendor. Try to have an honest discussion. And from my position in the industry, I don't get that question enough when I go and talk to people. And that's a question I really like to see asked. Because when someone asks me, how do I defeat your product? What are the vulnerabilities? What do I need to watch out for? I can have a more meaningful security dialogue with them, and I'm able to better see if our products are a fit for their environment and what additional steps they might need to make it most effective. So I think the first question you need to ask is what inherent vulnerabilities exist in the approach a security product has. And by that I mean no security product that is designed to do everything does anything well. All the best security products are designed to do one thing or a few things really effectively and efficiently. So you have to identify what that product isn't designed to do so you know what it won't do. So look at signature-based antivirus. Its design is to detect something it knows is bad and prevent it from running. And at that, it does a good job. The problem is people expect it to do something it's not designed for, like detect unknown malware. So if you're expecting it to do that or relying on it to provide that functionality, you've created a vulnerability in your environment. Similarly, application whitelisting. It's not designed inherently to prevent a whitelisted application from being exploited and having malicious code run on it. So if you're relying on it to do that, you've created a vulnerability. So that's kind of the first step. Ask what inherent vulnerabilities exist in it so you can understand where you still need coverage or what you need to do to mitigate those. Then another thing you need to consider is what sort of vulnerabilities are exposed from the ease of use features you enable. And by that I mean security products often give you ways to make it easier to manage a product or to minimize the impact on an end user. The problem is most of these sort of ease of use things also create new security holes. So to the question that was asked earlier, why are you going to trust a certificate from Adobe or Microsoft if you have reason to believe that it might be spoofed or illegitimate or somehow otherwise tricked? And that reliance becomes a new vulnerability you have to keep in mind when you're implementing a product. And to that point, I'll go on a little rant here, and that's public key cryptography is a great technology and a lot of really important functionalities built on top of it. And when it's used for what it's designed for and how it's designed to work, it works really well. Unfortunately, I think in the security industry, people have taken it and tried to apply it to an environment it really wasn't designed to work in. What public key cryptography wants to do is take a trusted source A and a trusted source B and ensure that this untrusted link between them isn't able to interfere in some way with data that's being sent between the two, which works pretty well until you no longer trust your source A. So say for instance, in the case of Stuxnet, when they infiltrate J-Micron in order to get their legitimate certificate to sign their own malicious code, now all of a sudden, if you're relying on this trusted source A to say that software is good, it's telling you Stuxnet is a good piece of software you should allow to run in your environment. And that's obviously a vulnerability. And I think it's a particularly large vulnerability because the hardest organizations to secure are actually the software development houses, because they are constantly churning out new code, so you can't rely on techniques like application whitelisting. Behavioral solutions typically have a lot of trouble with them as well because they're usually implementing more sophisticated technology and techniques just from the coding. And then also you have a bunch of administrators running in an environment with high level access, and that in and of itself becomes a vulnerability. And then even to take it one step further, the people who are developing particularly effective malware tend to be pretty good coders. So if they really want to, all they need to do is get a job with an organization they like the certificate of, infiltrate it from the inside, and now they have control. So that's one problem with trusting these certificates entirely as part of a security solution. The other part of the problem is if you don't trust your point B. And as I demonstrated with our demo, I can change the way a computer views its certificates. So something that you think it should be accepting, I can change it to point to my fake cert store. Or if I wanted to, I could use that kernel level driver to tell you that a executable that isn't signed by a legitimate thing was actually signed by Microsoft, just by changing the bits that are read in by it. So the problem with this sort of reliance on certificates is that you have a technology that is being sort of misapplied. And it's not a problem if you're not explicitly relying on it, but if in order to use a security technology, you need that to be something you trust, then you're going to open yourself to a whole host of vulnerabilities you wouldn't have if you had gone with something that didn't suffer from that. So that's kind of one of the takeaways is don't rely explicitly on certificates to provide security. Use them as an additional way of establishing whether something's trusted, but don't just close your eyes and trust everything that happens to be signed or looks like it's signed. And then finally, you need to ask how a product from a security vendor can be attacked directly. So if you look at a lot of the malware being developed today, it's designed to directly attack the security products it knows about. And that becomes a real hole. And if anyone should know how that product can be attacked, it's the person who's actually building it. So I think the important thing is you ask these questions, because without that education, you don't have the information you need to actually provide an adequate security model around your organization. And the reality is the first person you're going to talk to at a specific vendor probably isn't going to have the answers to these questions. So you should really be burrowing down and be insistent about talking to someone who can have that sort of honest, open dialogue with you about these vulnerabilities. And if a security vendor isn't really willing to honestly discuss those vulnerabilities, and if you have to sign an NDA or whatever you have to do, jump through the hoops to do it, but if they're not even willing to talk to you about that, I'd say look elsewhere for your security, because how can you protect your organization when you don't know what you don't know? So that, I think, is kind of the first step at, what do we do about these vulnerabilities that exist in security products? And then I think the second step is don't stop there. I think the really easy tendency is for someone in the security field to get a shiny new toy or security tool, implement it, and think that they're done. And I think that's really tempting, and it makes a lot of sense until you realize that there's these vulnerabilities that are present. And what I'd say is, instead of stopping at the deployment of a security technology, take the time to look at those inherent vulnerabilities you learned about and see if there's anything you could do about it. So, for instance, in the demo, I demonstrated how there's an inherent vulnerability in an application whitelisting product that uses a kernel driver. If you slip yourself underneath, it can't do anything about it. So you have to ask yourself, do I have an existing tool that exists in my organization I can use to detect that sort of behavior? So if you have something that's capable of detecting a new driver being installed, put in the registry or in one of those system locations, well, now all of a sudden you've managed to patch up a hole that they had in their product and you're safer for it. If you don't have an existing tool, then the question becomes, is this vulnerability large enough for your organization that you're willing to either buy an existing tool to solve it or develop your own? So in the case of our company, we looked at the products that are out there and we said, obviously, we don't like what they're doing, we're going to do our own thing. Now, I don't expect most organizations to go off and write sophisticated security software to solve those sorts of problems, but I think there's some areas where they can actually do little things that make a big difference. So I think the first thing is, that's a little bit easier to handle, is to ask yourself, how can a product, how are those ease of use features exposing me to more vulnerability? So if there's an ease of use feature you don't absolutely need to manage a security product effectively, turn it off. That's simple, it provides you with a greater level of security and you aren't exposing yourself to the same risk. And then I think the other area that's a lot easier to address is simply the direct attacks on a product. And I think that might be a little counterintuitive first until you think the way a malware developer thinks. So when a malware developer wants to attack a product directly, typically what he does is he goes out, he acquires a version of that product, either by downloading their demo, as I did in this particular instance, or torrenting it through something, and they install it on a computer. And they literally test things against it to see what works and what doesn't. And when it works, they use it, and when it doesn't, they don't. So before they've ever released a piece of malware, they know whether it's going to be successful against any given product. Now, what you can do is if you create additional checks and balances to ensure that that product isn't being attacked directly, you kind of wrestle that control back. Because a malware developer isn't going to have direct access to your environment unless you have either an insider situation or a highly targeted attack, which means they don't know what checks you've put in place. So while that technique may successfully disable a security product, if you see a security product disabled, you now have intelligence and know that you have malware present on that computer, or you have some kind of security malfunction which you'd want to know about anyway. So I just want to give a few examples of kind of simple things you can do to put that in place. The first is to simply create your own script that triggers a reporting event by that security product. So most organizations are kind of reliant on the reporting that comes back to them, but I don't think a lot of them go to the extent of testing on a regular basis whether that security product is working. So literally, if you have signature-based antivirus, put a known malicious file or a test file that is flagged as malicious, and install it through whatever software deployment tools you have on each client in your environment. And then see if it gets quarantined and see if it reports. If you see that it hasn't been reported, you know that security product's not working. So either the product's malfunctioned, and that's important information because you want to address that, or some malware that's present on the computer has somehow subverted the reporting characteristics, or has changed the way it operates so that it no longer sees that file as malicious. And by taking that step, now you've addressed a flaw that security product had in a way that malware developers aren't able to really detect. And then a second example would be to look at the yes.
Paranoid person that I am. The fact that you put a test file on there, even if it reports the test file, does not necessarily mean that you have a problem.
Correct. Yes, and there are additional steps you can sort of take around that as well. The intention is to put something in place, like take some sort of steps to ensure that the reporting is working as expected, because particularly sophisticated malware is going to change the mechanism by which those products report. So on your end, it's going to look like it's functioning just fine, and it's going to modify it in some way so that you don't see what's actually going on in that particular computer. But yeah, to your point, it might be doing it in sort of a more sophisticated way, only not reporting something that gets one of its own malicious files or things of that variety. And that sort of method isn't going to be detected by this, but at the same time, you're dealing with a situation where you are no less safe for having implemented this, and as long as you're not making the assumption that it's foolproof in its entirety, if that makes sense. So, and then the second thing I would say is to monitor for, use a tool to monitor for the status of a process execution. So if you have a antivirus product on that computer, one of the common techniques is to disable it in some way. So it's going to shut down its processor, things of that variety, and then maybe change the way it reports. Well, if you have your own agent on that computer watching to see if that process ever dies in an unexpected manner, and you're reporting it back through some other channel malware developers aren't aware of because they weren't able to take it off the shelf and install it, now you have a way to detect that sort of event occurred. And again, it might have been a crash of the antivirus product, but you probably want to know if it's crashing in a way that's unexpected. Or you have malware present on the computer that has shut it off, or a user who has admin rights who shut it off. And again, this is all important information you'd want to know, but it's something you're not going to get if you simply install a product and walk away at that point. So the basic advice I'm trying to give is just, if there are little things you can do to address the vulnerabilities you learn about when you're talking about, or when you educate yourself about a security technology, you can stop being that sort of low-hanging fruit that malware developers are after, and you're able to better secure your organization as a result of it. Were there any questions around that? Okay. So that's essentially it for the talk. The takeaway is every product's going to have some vulnerabilities, so take your time to educate yourself on it. And once you do that, if you can take the additional time to implement some other security measures around it, you're going to be better off for it. So, any questions now that we're at the end officially? Yes?
Yeah, how can I get my mustache?
Lots of laughter. All right, thank you very much. If anyone has any questions offline, feel free to talk to us afterwards. We're more than happy to discuss it.
So we'll take about a 10-minute break and come back about 7:30 and Dave will get his on. So lots of food left.
I hadn't seen it before.